Okay. And so, get rid of this. And there's the, so A, we need control 9, T equals negative 0.01 T squared. Remember that control 2 and or shift 2 and shift 3 are automatically square exponent and cube exponent. But if you use shift 6, it'll work as well. So I entered this in GC, and does it graph anything? I hit enter, nothing's graphed. Why not? Why doesn't anything get graphed here? Okay. Okay, what if I did A of X?
Yeah, that too. That works too.
It works. Does it graph it? If I do this? What about that? So let's, will that graph it? Does that graph something? What do you think, Richard? Is that going to graph something?
I do not believe so.
Okay. Why not?
I believe if GC is functioned in the way it does, I can hear myself. GC can graph functions y as a function of x.
Okay. So what is this doing? If it's not graphing something, what is it doing? So I put x's in there. Right. So exactly. So it's saving a relationship. It's telling GC a relationship, a function, right? We're defining a function. Is a function the same thing as its graph? How does its graph relate to a function? What's the relationship of a graph to function? What's that? Right, it's a visual, it's a representation of the function, but it's not the function definition itself, it's just one way of representing or expressing the function. Okay? So in a function definition, even symbols that are reserved for special use in GC don't take on no special use. So a of x negative 0.01 x squared, etc. So these x's are just strictly pertain to this line, and GC knows that that's your independent variable. That's what's called a dummy variable. Okay, so we could even do something like this. This is pretty weird. What about this? So in GC, that's a valid way to define this function. And it's seeing these f's as two totally different things. This f it sees as the name of your function that you can call on later. This f is just strictly being used in this line, and it's not seeing it as the name of the function. It's just using this line as the independent variable. Okay, so I want to point that out. So let's go back to this. So all three of those lines would do the exact same thing. They define this relationship. And then we use the relationship. We can graph it, we can use function notation, etc. Right? Okay, so we want to graph it. And Sarah says, so what about y equals capital A? Since our independent variable is t, I'm going to do y equals capital A of t. And now the graph button comes up. What's going to happen when I graph it? What's going to happen? Am I going to get the representation of the function A? Okay, so all right. So Angel, what do you think? Is this going to give us a graph of the function A?
No.
Okay, what will it give? What do you think it's going to give? So don't do this. I'm going to ask lots of questions before I graph. So don't be typing in and don't spoil it for yourself. Do you have any idea what you think it will do?
Will it give like a line?
Okay, can you tell me about the line?
Will it give a horizontal line?
Horizontal line. Okay, keep going. At what value? And you can tell me any way to express that value. You don't have to do a calculation in your head. You can just use notation if you want to express that.
Is it A of 1?
He's saying give a horizontal line at A of 1. What do you think? Donna looks at Ashley. Not sure. So what are we doing here? We're calling on the function that we defined. And what is capital T? Is it seeing capital T the same way it does here as in the first line? No. How does it see it now? Yeah, parameter, right? So this is actually now taking out a value, whereas here it didn't. It's just taking out a place. It's a placeholder. So what value does it have? 1. So we're going to get the horizontal line at 1. We get the horizontal line at 1. At what? A of 1. Good. Good. You don't see. She didn't need to calculate it. She didn't need to go, oh shoot, I got to calculate that. A of 1 is perfectly fine, right? A of 1. It's going to get a horizontal line at A of 1. Still can't see it. There it is. So whatever this value is, whatever that says right there, 13.16, that's A of 1. So how do we graph the function? How do we graph the function? You're all thinking it, right? Yasra, how do I graph the function?
A of x.
A of x, okay? So now GC is these values for x and y are the way that GC has for their special use. X meaning a spray of values, all values, x values graphed, and corresponding y values graphed according to the function A, right? Turn that one off. And then we can zoom out, get a good view of it. It's pretty decent. And then we want the only for, what did we want it for? 0 to. Okay, good so far? Okay, so then you had to come up with a calculus triangle, say starting at 35 degrees. We want to show a change of 12. So at 35 here, I want to show a change of an increase of 12 degrees and the corresponding change in expected attendance for that change in 12 degrees. How do I do it? Elizabeth. Let's do this one first. Let's do the dx. So y equals, am I going to do y equals 35?
Yeah, because you're past that, like, yeah.
So I want the change in x that starts at x equals 35.
It would be like A of,
Right.
because you want like the height of like what it would be past that 35.
Okay. And then I want to show that.
You need to restrict your domain
Uh-huh.
because you're doing 12, so it would be 35 less than x less than 47.
Good. All right. And let's make that black. Okay. There it is. You can see it. Okay. How about this corresponding change in y? Donna, can you tell me that? How will I get the corresponding change in y now?
X equals 47 from A of 35 to A of 47.
Okay. And what's going from a of 35 to 47? X?
Oh, I mean what?
Final answer?
Mhm.
What? Make that black as well. All right, how we do? Is that right? We get it? Okay. So then in this activity, you were asked to do this and make this thing move, right? You were asked to make it dynamic so that we could do this for any starting value of x. And so my question to you was, how did that go? How was that compared to doing this? Did it feel like that was like a cognitive jump? Did it feel like it was harder? What about you guys, remote?
It was a little hard because like we're not used to like thinking of n as being like that changing variable.
Okay. Yeah, so there's something that happens when we bring a variable into it that for some reason makes it harder. But my kind of contention is that it shouldn't be, right? So then once you figured it out, then did kind of the light bulb go on like, oh, it's the same thing, right? Hopefully you experienced that. Yes or no? Kind of. So what is n representing? So we're going to bring n into it so we can get this thing dynamically. And what is n going to be? So in this, like relative to this situation, what is n that we're going to be able to change? Yeah, Elizabeth.
It's like a very input, like, so it represents like an input at like any time into the
Okay, so it's an x value.
Yeah.
And then in this, so relative to this, which x value is it?
So like for right now, our situation, it would be like n is equal to 35 right now.
Right. I think this is the key right here. To see that the 35 is the kind of base, it's like our thing that we want to start changing. So n is going to be our current value of x. That's going to take on 35, and then all we have to do is change n, and so then we just have to adjust everything else. So let's do it. So 35 is going to take on n. So what will it be? This will be n. Keep going, Ashley. So n. Was it 10 in the actual thing? I made it 12, so for us it'll be 12. Okay. All right, and then what about here? Want to keep going? So what does the 47 have to do with the n? That's all we have to figure out. What does the 47 have to do with the n? Plus 12. So can you give me some insight on what is it? What is the way of thinking, or what's the what's the light bulb here that gets students from this to this? It would be a great research experiment to interview students who could be pretty confident that they could set up this, but then suddenly when they're asked to do this task, oh, it's like elusive, right? We can't get it. So, any insights on what happened? Anyone was paying attention to their thinking, and what made it click, or what made it difficult? Let's see those right first. Looking good here. Anybody have any insights about the challenge of this? That's what I want to get at. Like,
I think it's once you use like a symbol to represent a quantity, that's where students start to get confused.
okay, a symbol that represents a quantity. He said when you have a symbol that represents a quantity, that's when it maybe gets a little more abstract. Yeah.
I think I would even add to that like the change in quantity even like makes it harder because like you have to think of it in like multiple different situations and not just like one situation.
Right, exactly. Well, so maybe it's being able to see a particular situation that kind of unlocks the door to that. Like, get maybe that's the obstacle is that, oh, I've got to, how is it that I'm going to do all of these? Like, how is it that it's going to represent this changing situation when thinking of it more statically at first might be helpful? Does that make sense? Okay, any other comments or questions on that? And I think it's practice too. I think the more times you're forced to be put into situations where you're using variables to represent a changing quantity, it's going to become better, right? So you just have to practice. If it's something new, it's not quick and easy, and that's fine. But then with practice, we get better. Okay, so then what happens over here? Something happens over here on the right side of the graph where we lose our vertical line. And so what happened with this? Sarah, can you remember your thought process? What happened?
So when I was going through it, I knew it'd be the same statement that we had for the last line.
Okay.
But our range values are no longer valid.
Okay. Why?
After I think it was like 73.
Okay. So why? Why is this range? Is this thing right here?
Yeah, this range.
What's going on here that this is no longer valid?
Because as the graph is increasing up until 73, so our output values of n plus 12 are going to be larger than a of n.
Okay.
But once we get to 73, a of n plus 12 is no longer larger than a of n. So it would have to be like a of n plus 12 is less than y is less than a.
Okay. Cool. So good. So let's do something here. Let's do a little exercise. So yeah, good job. So this means that both are true. Both y is greater than a of n, and also y is less than a of n plus 12. Would you agree? I'm going to turn these off for now so I can see the graph. And so now I want to know if I were to turn on these two lines in GC, what am I going to see? Y is greater than A of n. What do you think I will see? What's GC gonna do with that? Donna, any idea?
Maybe a line.
A line? What line?
I don't know what line. What is it? Would it do that thing where the line goes like dashed
A dashed line?
and then it's like shaded on one side?
Shaded on, okay. Where? So be specific. It'll shade it in between? What do you think, Ashley?
I think it'll like graph a line, I guess, between whatever your AN is at the time.
Okay.
Or just, it would follow 100 also.
Okay. How about Angel? Any idea? Say y is greater than A of n. What will that do?
I'm not sure.
Not sure? Richard?
It creates a dashed line at a currently 9.60, where the horizontal line is, and it's going to shade the area above that.
So you're imagining a line here at this level?
Yes.
So imagining a line at A of n, you're saying it's going to shade everything above that.
Correct.
Sarah agrees? So when GC graphs something, what does it graph? So just in general, anytime GC graphs something, what is it graphing? Points. Either one point or a set of points. So we're asking ourselves, what set of points are we going to see? What set of points is where y is greater than A of n? And right now n is, whatever that says, 90 something. So what set of points is y greater than A of n, which is this value, or sorry, A of this value right here? Yasra, what do you think?
I'm a little confused because like in my head I'm like y is the same as A of n, right?
Well, this is a statement. We're saying we want all points whose y value is greater than A of n. So all points whose y value is greater than A of n.
You can shade above the curve.
The shade above the curve. Like up like this?
Not the whole curve. Just the part of the curve which has points that are narrow.
Elizabeth, are you?
So we're at 96.
Because of the machine, I need you to talk a little.
Sorry. So there's like a line right now at like 96 right now. So like where the A of 96 is, right?
A of n.
With that horizontal line.
Yep.
So we're saying we want the y values that are greater or above that line.
That's right.
So it would pretty much extend that horizontal line and shade all of the.
That's what Richard said. Yeah, that's what Richard said. Exactly. Right? All points whose y value is greater than A of n, and n has a particular value right now, right? Not a of x. If it was y is greater than a of x, then it would be so above the curve, because for every x value you get a different a of x. And GC, when you put the x in there, will interpret it all the separate x values and their corresponding y values on the curve. But a of n, well, n has a particular value right now. A of n has a particular value right now, so these are all points. And then what about less than n plus 12 then? And will there be any overlap between those two sets of points? Is there any points they have in common? That's why this doesn't work. Because these two statements together make up this one. All points that are both green and blue. Which points are both green and blue? No, which points are green and blue?
For this case now?
Yeah.
Oh,
None, right? So none. So that's why this doesn't give you anything. Right? Because it's trying to say all y values above this one and below this one. Well, there's none. That's why it gives you this error message. And so then, like Sarah said, so what do we need? We want all y values above this one and below this one. That's why you switch your, make this the lower one, a of n plus 12, and this the higher one, a of n. Okay, and then y greater than, so just show the y greater than a of x to see how it's different. Ooh, red, it's going to be pretty intense. So y greater than a of x, well, it's going to take every individual x value and get every individual corresponding y value, and all the points whose y values are greater than those for every x. Okay, any questions on the assignment that we turned in for today? Just wanted to try to get ourselves in the mind of GC, but the mind of GC is just the mind of mathematics, the language of mathematics. Okay, we have to learn some keystrokes in GC, but we put the mathematics in, and GC returns, a response that matches that, right? Like when it's graphing, it's a set of points. Any other comments or questions on that? Okay, let's change gears here and look at this very outdated smartphone activity. A smartphone that only has 10 gigs. Is that pretty low? So, better than nothing, right? All right, so we got this 10 gig smartphone. I'm going to let the variable z be used memory on the smartphone in gigabytes. Okay? So I have an illustration here. I have a didactic object. And I want to ask you, what might I be showing in this image? Okay, if Z is, we use smartphone memory space in gigabytes. I have a red bar and a blue bar. What might this be showing or depicting relative to that situation? What do you think? So just toss out your ideas.
Is it like how much memory is used is anything that's actually plotted on the graph? But the two different colors are like what it's used for.
Okay, so you're saying maybe there's like two different apps on your phone, and this is one of them, and this is the other, in terms of how much space they use. We're just brainstorming. Don't feel like you have to be right or wrong. I mean, I have something that I've done, and we're gonna talk about that eventually. But just brainstorming here.
You know how like iPods
Okay.
Like they'll say like this much is being used by music, or like you have this much of your gigabytes taken up by video that you have on your phone. Or
Sure.
something.
Great. Okay, so red is how much is video, and blue is how much is music. Okay, sure. Any other ideas? How about relative to z? So, what about how about an interpretation relative to the variable z?
Wouldn't Z be both lines? Because both lines show how much of the space is used.
What do you mean by both lines?
So
So
red,
z,
blue.
but z is a variable, right? It takes on values. So when you say that, what do you mean in terms of z taking on values?
So it'd be like the head point of the like 5 point something.
So you're saying that what I'm currently showing is a z value of 5.3.
Yeah.
Z equals, this is showing z equals 5.3. Okay? Sure, that's a valid way to interpret that. Any other ways to interpret this? Could the end of the red bar be the value of z? And then what might the blue bar represent?
How much is remaining?
How much is well? So the smartphone has 10 gig. Has a
Oh, okay, I
10
see what you
gig
mean.
hard drive. So that's a given. So if z is this 3.2 or 3.3, then what might the blue represent?
How much is being used? Like right now? Like sometimes apps will be taking up like they'll only be using gigabytes as long as you're using the app.
Okay, like ROM versus RAM or something, like hard drive space versus okay. Bringing it back to z though. So yeah, so we're gonna call the red bar is showing the current value of z. What might the blue bar be showing?
What if it's like super fast outside Z,
Okay.
increasing it to like the new value of Z, not blue bar, so the change in
Yeah, so it could be like you're about to, or you just downloaded something, and so that represents what in terms of z?
what's like the
Change in z, right? Yeah, like dz, right? Yeah. The other ideas were fine. I mean, because I didn't tell you, but this is what I had in mind in terms of what I wanted to show. Okay, and so this I can now do this, and when I set n to. So what I want you to do is I got a worksheet for you, and then on you guys remote on modules, class handouts. I want you to, there's a new class handout on there. If you could get that, please. It looks like this is what it looks like. So this is the class handout in modules. If you would pull that up on your computer. Okay, if you guys want to pair up, you can. All right, so we're just doing page 1. For those of you remote, we're just doing page 1 that I'm showing. So we're going to assign a value for questions 1 through 6. Assign a value of the initial value of z, the final value of z, and the change in z. Okay, so like number 1, at first, 3 gigabytes of memory was being used. After you downloaded a file, 5.5 gigabytes of memory was being used. So I want you to write down what z is, z initial, z final, and dz. And then a formula that computes whatever the unknown thing was. So whatever of those three, whatever was unknown, you're going to write a formula that will compute that value. Okay, and for that first one, what formula did that, number one, that calculation revealed what formula? Ashley, did you guys get it? How about this? Everyone agree? You agree with that? Okay, so now I'm showing number 3. This is showing number 3. And what formula, Richard, what formula would you come up with for number 3? Same formula for number 3? Oh, I thought it said the file was 1.2 gig, so what do I want? So number 6, let's do number 6. So can we just jump to number 6? So 2.6. Is this number 6? Am I showing number 6 correctly? My eyes are bad, that's why I'm asking. At first, you had 2.6 gigabytes being used. You downloaded a file that was 1.5. I think I got it right. Okay, so Richard, can you tell me what formula that one would imply?
When you say unknown, is it like defined, like ZF in this case?
So is that the one that's unknown?
Oh,
So at first you have
yes.
this much being used, you're given that number, and then the downloaded file took up this much.
ZI plus DZ equals ZF.
How about that? Agree with that? Is that what we're saying? Yeah, indeed. There we go. Agree now? Okay. So we use this early on in the calculus course, the Dirac calculus course. What do you think the purpose of this? Is this activity challenging or more on the easy side? In between? In between. So what do you suppose? What do you suppose the purpose of this is in the calculus course? What did I have in mind when I wrote this activity? What do you think my goal was? First. Yeah, exactly. So that's exactly what I wanted. I wanted students to get familiar with this concept of what does it mean? What does the change in a variable or the variation in a quantity? What does it mean when we represent the variation in a quantity? Getting students to think about variables varying is a challenge in itself because they've been so accustomed to it's the unknown. What is its value? We have to solve for it and find the value, right? So that's also another consequence of this, helping students to see variables vary, right? The value of z is changing. It's taking on lots of values as things get downloaded or erased. Okay. But then, so that's a good part of this. But then also, yes, what is this weird thing? The variation in a quantity or the change in a variable, right? And so what's tricky about it? Well, it doesn't start at 0, right? It could start at any z value, and then it represents this amount of change. Okay, so yeah, that was introducing the concept of the change in a quantity or a variation in the quantity. So now I have a different a different way to show this. Now watch this. So you see how this is the animation is going right now? Now watch this. Okay, I'm going to change it now. How is it different? Yeah. So the dz is changing now as z is changing. Does everybody see that? So what do you think? What do you like better? What's more realistic? What's your reaction to that? How about Yasra? Do you have any thoughts about the way that I changed it to show now dz changing along with z?
I think that the second one helps, like, it's easier to see the idea of z of f, but I feel like both ways help the student actually understand what dz is.
Sure. What about what's realistic? What's more realistic? So if I pause this like halfway through the download, what's kind of more, what matches reality better? First or second? Because? Right. Yeah, so as it's downloading, I'm actually not sure that that's the way it works. Does it like so in the downloading process, it's slowly bit by bit taking up the memory. Is that right? Okay, good. Yeah. So in the download process, it's the amount of space used is accumulating, right? And so at halfway through, when we've used up, say, 3.4 gigabytes, does it make more sense to think of dz as this value or as this value? It's like the change so far is this one, right? Change in your so far is this one. This is kind of maybe a snapshot of like what's coming, right? Like, so we have this file, and so we think about, okay, this is going to be my initial and final. But in the Dirac calculus, dx is a variable. And so for us, we want students to see it this way because in the course, a big theme of the course is that dx varies. I don't know if you remember that on the very first day we practiced with variables parameters, and I showed you that image and what dx was varying in every delta x interval. Do you remember that? That's a key concept in the curriculum. Okay, so yeah, so this is to really help students form a concept for what is a change, and we represent a change as dx or dz. What is that thing? What does that mean? So in a couple weeks, you're going to build this GC file. So little by little, I'm going to start with these GC assignments. You're going to learn different techniques, different tools, and then this is kind of the first challenging one. So all the other ones are a little less challenging. You're going to learn some basics and some parts and pieces of this, but you're going to build this. Pretty useful thing, right? This is a great teaching tool to help students understand what a differential is. And you're going to make it. Okay, so let's, any questions, comments about that discussion? So let's look at, let's take this a step further. Let's talk about, kind of summarize this and take it a step further. And of course, you can interject, stop me, ask a question anytime. I want this to be about as much discussion, questions as possible. So don't hesitate voice your anythings, concerns, questions, comments, observations. All right. So from that activity, from that worksheet, we came up with 2 essential principles. Given a variable x, the change in x, or dx, what do we come up with? What is that? How's that calculated? Or one way that could be calculated? X final minus x initial, right? The amount of variation is the final value of the quantity minus the initial. Okay, and then given a variable y, we came up with something that would tell us the final value of y. What would that be? The initial value of y plus the change in y, or dy. Okay? And these formulas should just make perfect sense, right? It should make sense in your brain and not just memorizing them, right? And that's what we want for our students. That as much as we can, formulas, the way that the quantities and the operations work together should make sense. You start with an amount of a quantity, you add how much change, and then you're going to get the new value, right? It should make perfect sense. Okay, so we said that dy was, so if dy we said is computed by y final minus y initial, but if y changes along with x in some relationship, dy can be determined a different way using dx. Do you remember what that is? Anybody?
dy equals some proportional constant times dx.
Okay, so dy is proportional to dx. All right, so this is the idea of constant rate of change, right? The change in y is proportional to the change in x. That's what constant rate of change is. All right, so we kind of did a little bit of this on the first day. What's the meaning of 70 miles per hour? That's a constant rate of change. What's the meaning of that? What does it mean, 70? The number 70, if you're going 70 miles per hour, you set the car on cruise control. For,
So if you know how long you've been driving for, you know how many miles you've driven.
okay, so those were 2 different responses. Okay, so every additional hour means an additional 70 miles traveled. Is that what it means?
Technically, yeah, but like we can talk about like half an hour and like other periods of time too.
Remember from first day? So yes, this is true, but it's narrow. We've said this before. It's a narrow meaning because we know how far you've gone in 2 hours. We know how far you've gone in 5 hours and half an hour. That's what Yasser said. How far have we gone in half an hour?
35.
How'd you get that? How'd you get 35? What'd you do?
By the number of hours times the miles per hour.
That's right. You take the change, the variation in time, times the rate, and it gives you the change in distance. So what do we do? 1/10 times 70 is 7. 7 miles in 1/10 of an hour. So you know all this stuff. You don't just know how far you go in an hour, you know how far you go in any change in time. How do we get the change in distance for any change in time? What do we do? What'd you do to get all these values? Multiply by 70, right? So this is a good meaning, a broad meaning. This is a meaning we can use to do calculus. If we only could use the fact that you go 70 miles in 1 hour, we couldn't do calculus. calculus would not be possible. Or I should say accurate and precise calculus. We'd have very bad approximations, very crude, bad approximations if all we were limited to was changing the independent variable y1, right? We need to be able to change it by any amount and smaller amounts.
I have a little question.
Please.
With direct calculus, is the objective to avoid using the term infinitesimal? Like to like rates of change? Or wait, no, infinitesimal changes.
So I missed the first part. Is it to do what regarding
Does
that?
direct calculus try to avoid using the term infinitesimal to
avoid.
describe like small changes?
Yeah, we just say really, really small. We say small enough.
Okay.
But it's not something that we like try really hard to avoid. It's not a term that we use, but we could.
Okay.
So we just focus on small enough so that we can call it a day and say that, it's close enough to exact for practical purposes. Okay, so what's the meaning of $2 per gallon? I think we also talked about this one. What's the meaning of $2 per gallon, constant rate of change? Donna, you want to give it a try?
That, no matter how many gallons you bought,
Mm-hmm.
you take the number you bought and multiply it by 2, and then how much you spent.
Good, yeah. No matter how many gallons you buy, you can multiply that by 2, and it'll tell you how much your additional cost is. So it's not just about how much 1 gallon or one additional gallon costs. For any number of gallons, the cost, or the change in cost, is 2 times that change in gallons. Okay, so suppose you have, store sells make your own snack gifts. The box costs $B and the snack mix costs $2.75 per pound. What does the $2.75 per pound mean? How about Angel?
That is that it costs $2.75 like for any variation in pound, like per pound, but that's like that scalar that you multiply by the change in x.
Okay. So we said given any what?
I'm sorry, what?
So you said that's the scalar you multiply by what? And what does it get for you?
So because the box costs $B and so sorry, I need to reread this.
Sure, okay. Elizabeth, what about you?
So for any change in like the pound, it's going to be 275 times that change in pounds, but it's plus the box as well, right? Because it's
So I'm just interpreting this much.
Oh, okay.
Yeah, so just interpreting the constant rate.
So then the constant rate would be like for any change in pound.
Yep.
Of the snack mix, it's going to be 275 times that change in like the pounds, like for the price of how much snack mix it is.
Okay? Right, so given any change in pounds, to get the additional cost or the change in cost, you would take 275 times that change in pounds.
Yeah.
Right. So how about for any number of pounds you buy, your cost will be 275 times the number of pounds. Is that right? Why not? Because you have to add the B. So do you see the difference between the two, right? So like what we were saying was for any change in number of pounds, right? For a dx, for a variation in pounds, the cost of the box doesn't matter. The variation in cost, or the change in cost, will be 275 times the change in pounds. And that's irregardless of how much the box costs, whether there's a box or not. So that's the difference between looking at X pounds or DX pounds, right? If there's X pounds, it doesn't cost 275 times X dollars. But if you have an additional DX pounds, the additional cost will be 2.75 DX. Do you see what I'm saying? Does that make sense? Any additional number of pounds will increase the cost by 275 times that additional number of pounds. So, quickly, what is each variable here in this situation? How would you define each variable? What is X?
Number of pounds.
Number of pounds. Number of pounds of snack mix. Y is?
The cost of snack mix that you buy.
Cost of the snack mix that you buy. With the box or not? With the box, right? DX is? Yeah, so the Y is the cost of a gift with X pounds of mix in it, and DX is? Some change in the number of pounds. DY? Some change in the cost. M is? Right, the constant rate of change, 2.75. Another theme in Dirac, we want students to, before just jumping into formulas and calculations, to understand and model the problem and understand what's going on, right? So modeling, we've got 5 different symbols, parameters and variables, right? Which are variables and which are parameters? Which ones are variables and which ones are parameters? X, variable or parameter? Variable, why?
Takes on multiple different values.
Yeah, it's variable, right? Y is variable too. What about dx? Variable or fixed? Yeah, variable, right? So we want to think of those differentials as varying. dy, likewise varying. M, parameter or variable? It's a parameter, right? So that it's constant in this situation. Constant rate of change. And so what's the equation using these variables that expresses the constant rate of change? What would we use to express the constant rate of change M with these variables and parameters? Yeah. Okay, but I want to compute the constant rate of change. I want to compute the constant rate of change. dy over dx. Yeah, so if it's proportional, no matter what dx you pick, you get the corresponding dy. That will always be in proportion, so it'll always be m. The change in cost for the change in number of pounds bought. What equation would calculate the change in cost for some change in number of pounds? dy equals mdx. Agree? Donna, you agree with that? It calculates the change in cost for any change in pounds. dy equals mdx. Yeah. Okay, so we'll stop there. I want to show you your homework for... So your homework for Tuesday, which is this. I have not posted yet. I'll post this afternoon. This is the laptop battery activity. We did a little bit on day one. I just were plotting some points and sketching some lines. But in this, part of this is you can define other variables to be sliders in the command lines, okay, in the math lines. So you have the built-in slider n, but you can do that, and I'll show you how you do that. So you go to make a string of characters into a variable or parameter. You hit the backslash. That's the one above return, backslash. Type it in, and then hit backslash again, and that gives you, so like I made dx, that unit, be the variable. And then you write equals slider, parentheses, and then starting value, ending value, and number of partitions, number of steps. So starting value, ending value, number of steps. Now, there's no play button for those. For the ones that are in math lines, you have to manually change them, okay? But that's going to be part of this. And what's going to happen then is when you work through the whole activity, it's going to be text lines and blank math lines where you're filling them in. This is going to be the result. As you change dx, it shows you a calculus triangle, but a little bit different than in the attendance temperature one. So what is this showing then? Specifically, what does this file show? What am I showing with that calculus triangle? This is?
Change in time.
A change in time, a change in x, but specifically, all these changes in time are what? From 35 minutes after class started, right? So by changing dx here in the slider, you're getting a certain dx with the reference point being 35 minutes, and then it shows the corresponding change in battery percent in your laptop when you do that. So that'll be the final product in that one. And then on Tuesday, we also have the first assessment. So longer than a quiz, but not quite a test. Okay? We have like 5 or 6 of those in the course. So the first one's Tuesday. It covers kind of everything we've done so far.